This is a multiple-choice question designed to test your understanding of how to adjust a Gaussian process regressor (GPR) model to improve prediction accuracy. Think of it like fine-tuning a machine to make it more precise. Increasing the alpha parameter increases the assumed noise level in your data, which will, in turn, increase the uncertainty in your predictions. It's like adding extra noise to your signal, making it harder to get a clear measurement. Decreasing the alpha parameter decreases the assumed noise level. This means I'm assuming my data is less noisy, which can lead to more precise predictions if this assumption is correct. It's like turning down the static on your radio to hear the music clearer. The kernel function determines how the model assumes data points relate to each other. Using a different kernel can improve the model fit if the current one is a poor choice for the data. Sometimes, you need a different tool for the job. Different kernels may be better suited to different types of data. More data points generally help in making better estimations of the underlying relationships in data, leading to less uncertainty in predictions. It's like having more clues to solve a mystery. The more clues you have, the more confident you'll be in your solution. The problem is that the Gaussian process regressor (GPR) model is producing predictions with high uncertainty, even in areas where I have a lot of data. This means the model isn't as confident as it should be in its predictions. This entire exercise is about tuning the parameters of a Gaussian process regression model. I'm trying to improve the model's performance and make its predictions more reliable. This is a crucial skill for data scientists. This section will provide explanations for why some of the multiple-choice answers are correct and others are incorrect. I will justify which answers will help reduce prediction uncertainty for the Gaussian process regressor. I will show you why some choices are better than others. I see a problem. Your Gaussian process regression (GPR) model is producing predictions with high uncertainty, even where you have lots of data. That's not ideal. Let's figure out why. Alpha controls the assumed noise level in your data. A higher alpha means you assume more noise, and that leads to higher prediction uncertainty. Let's decrease alpha. That's like saying, I believe my data is actually pretty clean, which would make your predictions more confident. This is a good strategy if your data is not very noisy. The kernel defines how your data points relate to each other, impacting the uncertainty. If you choose the wrong kernel, your predictions get unnecessarily uncertain. I recommend trying a different kernel, like Mattern instead of the radial basis function or RBF, to better capture the underlying patterns, potentially reducing the uncertainty. More data typically translates to more accurate model fitting and consequently, lower uncertainty. Think of it like this. The more information you give the model, the better it can understand the patterns and make more precise predictions. This is the core question. We're looking for ways to improve your model to get more precise predictions. To summarize, decreasing alpha, option B, trying a different kernel, option C, and using more data, option D, all offer potential solutions to reduce prediction uncertainty in your Gaussian process regression model. That's it. I hope this makes sense. I'm happy to go over any of this again. I see high uncertainty in my Gaussian process regressor predictions. That means my model isn't very confident about its predictions, even where I have lots of data. Let's figure out how to fix it. Increasing the alpha parameter increases the assumed noise level in the data. Think of it like adding more random noise to your measurements. More noise means more uncertainty in the model's predictions. That's not what we want. Let's try lowering alpha. This means I'm assuming there is less noise in the measurements. With less assumed noise, the model becomes more confident in its estimates, resulting in lower prediction uncertainty. But, be careful. If I underestimate the noise, the model might overfit to the data, making it less reliable on new data. Let's see if it helps. The kernel function determines the model's assumptions about the relationship between data points. Using a different kernel, such as switching from RBF to Mattern, could better capture the underlying data structure. A better fit means lower uncertainty. With more data, I have more information about the underlying pattern in the data. This helps the model make more accurate and confident predictions, which leads to lower uncertainty. More data is usually a good thing. I'm facing a problem where my predictions using Gaussian process regression, GPR, are very uncertain, even with lots of data. This means I'm getting wide confidence intervals around my predictions, making them less reliable. Alpha represents the amount of noise I'm assuming is in my data. If I decrease alpha, I'm telling the model that the data is less noisy, which should make my predictions more precise and reduce the uncertainty. The kernel function determines how data points relate to each other in my model. If I use a more appropriate kernel function, it might better capture the structure of my data, making for more accurate predictions and reducing uncertainty. Think of it like choosing the right tool for the job. More data generally leads to better model performance. With more data points, I have a better idea of the underlying patterns, resulting in less uncertainty in predictions. It's like having more evidence to support my conclusions. I'm focusing on how to fine-tune a Gaussian process regression model. GPR is a powerful technique for regression tasks, predicting continuous values. Model tuning involves adjusting parameters to optimize prediction accuracy. In this specific problem, I'm trying to reduce prediction uncertainty in a GPR model. My GPR model is giving predictions with wide confidence intervals, even where I have lots of data. This means my predictions are not very precise. I need to figure out how to make them more certain. I am exploring ways to improve the certainty of my model's predictions. I'm examining several changes to the model and the data to see which ones will have the biggest impact on reducing the uncertainty. The alpha parameter represents the assumed noise level in my data. If I decrease it, I'm telling the model that there's less noise, which should lead to more confident predictions. But, be careful. If I make alpha too small and there's actually lots of noise, my model will be overconfident and inaccurate. The kernel function defines how data points are related. Different kernels make different assumptions about the data. If I choose a kernel that is more suited to my data, the model can fit better, resulting in less uncertainty. I might change from a radial basis function, RBF, kernel to a Mattern kernel, for example, depending on my data's smoothness properties. With more data, my model should be able to learn the underlying pattern more accurately. More data equals better estimates, and less uncertainty. I'm focusing on how we can adjust the settings in a Gaussian process regression model to improve its accuracy. Gaussian process regression is a powerful statistical model that uses probability distributions to make predictions. We're specifically interested in tuning its parameters. I'm facing a common issue. My predictions from the Gaussian process regression model are too uncertain. Even when I have lots of data, my model is still hesitant to provide a confident prediction. That's not very helpful. I can try lowering the alpha parameter. Alpha represents the noise level in my data. A lower alpha assumes less noise, which generally makes my predictions more confident. However, I need to be careful not to underestimate the actual noise. Otherwise, I might get overly confident and inaccurate predictions. I can experiment with other kernel functions. The kernel function determines how my model measures similarity between data points. Different kernels have different assumptions about how the data is structured. If I choose a kernel that better fits my data, the model will likely give me more accurate and less uncertain predictions. I can try to add more data points to my training set. More data generally leads to better estimates of the underlying patterns, leading to more certain predictions. It's like having more evidence to support my conclusions.